All right, for this part of test 2, I chose problem number 2. As you can see, we have the balloon's weight, which is 0.029 kilograms, and the distance of 19 meters. And we know that the acceleration is 1.1 meters per second squared. All right. First, we have to find the magnitude of this charge on each balloon. Since we already know that 0.029 kilograms is the mass and 1.1 meters per second squared is the acceleration, let's use Newton's second law, which is F equal to ma. So all we do, we just simply multiply that into 1.1 meters per second squared, and it comes out to get 0.0319 newtons. All right, so we can save that number for later. Now that we have that, we're able to move on and use F is equal to K, Q squared over R squared. So K is the Columbus constant. I'm pretty sure I spelled that wrong. And Q is the charge of the balloon. And R is the distance in which they are separated. Okay, so we've labeled everything. Now we can get right into it. We already know F. So now we have to find Q, which is the magnitude of the charge. So the equation that we use now to find Q is equal to FR squared over K. Now we plug in chug. We can go back to this number, which is 0.0319, and we multiply that by the distance, which is 19 squared over 9 times 10 to the 9th. And what it comes out to be is 7.16 times 10 to the negative 5. So that's part A. I'm sorry, that's part A. Now we have to find part B. Now that we solved the first part of the problem, we can move on to the next. We know that the magnitude of the charge of one electron is 1.6 times 10 to the 19th. Now, using our answer from the previous problem, which is 7.16 times 10 to the 5th, I'm sorry, I'm a little lost. I lost myself. Okay, yeah. So this is the answer from the first part of the problem. And this is the charge of one electron. So since we're finding the charge in, we have to divide our answer, which is 7.16 times 10 to the negative 5. And we have to divide that by 1.6 times 10 to the 19th. And this will come out to be So it'll come out to be 4.475 times 10 to the 14th. So that is the answer for part B.